So what like is Pythagorean theorem, is that the next thing for us to work on, for you to work on in this class?
Well, what I was working on was more, it was the view it's down.
Okay.
That's like a more recent one that I wanted to work on and finish. I only have two things left to do.
In unit one, you're saying the converse of the Pythagorean theorem?
Yeah.
Okay. All right. Perfect. Okay. So we could work on a problem like this. Is that okay? All right. So let me snip this in. And so this is the screen that I normally share the entire time. I call this the workspace. And I snip in the questions we're going to work on. Okay, like this. And then I work them out for you, or I have them work them out, have you work them out. Now, at the end of the lesson, I'll send you this as a PDF, but we're also screen recording the lesson as well. So you could go back and look at this later on if you need to. Okay, so if you're with me, and you're welcome to take notes, we'll just see how it goes here. So it says, which of the following sets of numbers could not represent the three sides of a right triangle? So what you're looking for, let's just look at three numbers that do work. Have you heard of a 3, 4, 5 triangle before? Jasmine, are you there?
You kind of cut off at the end.
Have you heard of a 3, 4, 5 triangle before? 3, 4, and 5.
No.
No. Okay. So these sides work. These sides in a triangle absolutely work. Now notice that the two smaller sides, 3 plus 4, which is 8, is greater than 5. It's greater than the longest side. And notice that when you subtract the largest side and the smaller side, which is 1, it is less than the shorter side. So these two things have to be true. Okay, so let's just take a look at the I don't know, we'll just take a look at this one on the right here, 14, 18, and sorry, 14, 48, and 50. So is 14 plus 48, is that greater than 50? Is that true? Well, 14 plus 48 is 62. So yeah, it's greater than 50. Okay, so that's good. Now you have to do the other way. You have to take the larger side 50, subtract the other side 48, and is that less than the short side? And 50 minus 48 is 2. That's less than 14. So this one is good. This one works.
Okay.
Are you able to hear me well? Because the connection doesn't seem to be very good between us, and that's probably part of the reason we've been having some of the issues today. But you're able to hear me now?
Yeah. It's just, it like cuts out a little bit.
Yeah, I'm seeing that too. So I'm seeing that. Let me just look at this on the yeah, it's not a great connection for us today, but we'll do the best we can here. Maybe it's just a function of when people are getting home. So let's look at this next set of numbers, like 60, 63, and 87. So you add 60 and 63, okay? That's 123. And is that greater than 87? Yes, it is. So that's good. Then you take the two larger sides, 87 and 63, you subtract them. That's 24. And is that less than 60? And yeah, it is. So that one also works. So you might be thinking, well, maybe they all work, right? Well, let's look at the answer. This is actually the correct answer here. So is 12 plus 35, is that greater than 37? I'm sorry, let me back up here. Is that greater than 37? Yeah. So so we have 47 greater than 37. That's good. But then you have to take the two larger sides. Okay. And then you have to see, is that less than 12? And that is also good. 2 is less than 12. So it looks like this is the answer that does not work for us in this problem is the last one here. Although I think these all work. That's sort of odd. Huh. So I don't understand this. Does it give you immediate feedback, or is it like because everyone's a little bit different in this, but do you
I get 2 tries.
oh, you know what? I'm so sorry. This is asking about a right triangle, not a triangle in general. Okay, let me back up here. I made this way too complicated. I apologize. So there's actually something much simpler. Have you heard of the Pythagorean theorem? Pythagorean theorem. So the Pythagorean theorem says that a squared plus b squared equals c squared. And a and b are the shorter sides. Okay. So for example, it's asking you is 12 squared plus 35 squared, does that equal 37 squared? So do you happen to have a calculator handy? I didn't hear you if you did. So 1369 is 12 squared plus 35 squared. And then we calculate 37 squared, and that is also 1369. So this one works. Okay. We want the one that does not work. So we just have to move down the list. We have to take the next grouping of numbers and ask ourselves, is 14 squared plus 48 squared, does that equal 50 squared? And this is the Pythagorean theorem. This is a squared plus b squared equals c squared. You're going to see this all year long. You're going to use it over and over again. So 14 squared plus 48 squared. Okay, that's 2,500. 50 squared is also 2,500. So this one also works. Okay, so let's try the next one. Let's try the 42 squared plus the 56 squared. Does that equal 69 squared? And I'm just going to my calculator and calculating this. I'm not doing anything special. I'm not using any of those tricks you see on TikTok to multiply. I'm literally just squaring them and adding them together. Okay, now this one appears to be the one that does not work. 69 squared is 4,761. So this does not work. And that's the one we're looking for.
Okay.
Okay, so just to be clear, if a squared plus b squared equals c squared, that's the one that that we're looking for, and the one we just tried there does not work. Okay, so let's go to the next problem, and it's the same thing here. So let me grab this here. I thought you were in a different part of the course, but now we've got it. So it just says which of the following numbers could represent the three sides of a right triangle. Right triangle is always governed by the Pythagorean theorem, a squared plus b squared equals c squared. And one of these combinations of numbers will work. Okay, so I want you to try this one for me. I want you to grab your calculator and do 10 squared plus 24 squared and ask yourself, does that equal 26 squared?
It's they equal same thing.
Yeah, this is the one that works.
Yeah.
Okay. Now you might be thinking, well, how does Matthew
Yeah.
know that? Because that he can't square anything that fast. There are certain what are called Pythagorean triples that you're supposed to know, and one of them is 3, 4, 5. The other is 5, 12, 13. But what's really cool is that if you multiply these numbers, see how if you multiply 5 by 2, you get 10, 12 by 2, 24, 13 by 2, 26. That's how I knew to have you check this one, because it's a Pythagorean triple. It's one that works really nicely. Okay, otherwise you're just testing the numbers until you are tired. Okay, let's look at another problem here.
Okay.
All right, so which of the following sets of numbers could not represent the three sides? Okay, so again, this is an a squared plus b squared equals c squared problem. They're all the same. That's kind of one of the nice things about Delta Math is you get a lot of the same questions, good repetition. So like this 3, 4, 5, 3 squared plus 4 squared equals 5 squared. This is a Pythagorean triple. This one always works. Okay, 9 plus 16. Does that equal 25? Yeah, it does. Okay, so we don't need to try that one. What do you think we should try next? Do any of these numbers look odd to you that might not work?
Um, 76,
Yeah, let's try that one. Let's try 57 squared plus 76 squared equals 95 squared. Do you have a calculator handy to try that?
yeah.
Okay.
It's greater than
95 squared. Right?
Yeah, do you have a final answer for me on that? So 9,025 and then 95 squared is also 9,025. So this one works. So we know that's not the right one.
Okay.
Okay. Now, the nice thing about multiple choices is that if, like, let's say we do 25, 16, 65, if that works, we know the answer is this one on the right. Or if we get 25, 60, and 65, if that works, then we can just immediately be like, okay, we're done here. So let's try it. Let's try 25 squared plus 60 squared. Does that equal 65 squared?
Yeah.
This one does work as well. So this is clearly the correct answer. Now, here's what's interesting. Remember I mentioned 3, 4, 5? Well, if you multiply 3 by 4, you get 12. 4 by 4, you get 16. And 5 by 4, you get 20. And that's why this one does not work. If it was 20, it would work. But because it's 21, it does not.
Okay.
So I think this is actually trying to get you to be better with Pythagorean triples. But we can just keep using the a squared plus b squared equals c squared for this. Okay, so let's look at another problem here. So this one is, we want to find the one that the one that does work. We're looking for the one that does work here. Do any of these stand out to you? Do any of them, do you say, oh, let's try,
33, 44, and 55.
Okay, so let's try it. 33 squared plus 44 squared. Does that equal 55 squared? You've got a calculator. Let's see if that works.
Um, yeah.
That one works, doesn't it?
Yeah.
Okay. And notice, so again, see how it's a 3, 4, 5, but you're multiplying by 11 each time.
Yeah.
So that works. Okay. Let's try 30, 40, 49x. 30 squared plus 40 squared plus, does that equal 49 squared? Oh, wait, I'm sorry. We want the one that does work. So we're done. We're done with that.
Okay.
All right. So here's what I'm gonna do here. There's one question left, but I think you can do that on your own. Let's go back and look at the level 2 problems here and see see if we can work through some of these. All right. Okay, so the sides of a triangle are 25, 20, and 15. Use the Pythagorean theorem to determine if the triangle is right, acute, or obtuse. So in this problem here, that it would be good to draw a picture. It is always the case that the legs are the two shorter sides, so 15 and 20, and the hypotenuse is always the longest side. Okay, so that's your A, your B, and your C. So could you do this for me? Could you do 15 squared plus 20 squared and tell me if that equals 25 squared?
Yeah.
This works, right?
Mm-hmm.
Okay, so here, and I grabbed this from your notes here. Did you see this in class, this table? Did you happen to see this table? Yeah,
Yeah.
so the ones we've been doing all have been right triangles, but the other two, acute and obtuse, they're based on this formula here. So you're going to have to commit this to memory. This is something you're going to have to memorize. And it's easy to mistaken, you know, which direction it is. So find something that helps you to remember that. I mean, you can go to TikTok, you can, you know, YouTube, find some songs, whatever you want to do. But in terms of answering this question, the first drop down is one of these options. This is obviously a right triangle, okay? And it's because the square of the largest side is exactly equal to the sum of the squares of the other two sides. Does that something you've seen in class?
No, not for a whole week. So
Okay.
yeah.
All right.
Something I didn't see.
All right. So let me grab this next question and we'll look at it. Okay, so it says here are the three sides of a triangle. They're 54, 39, and 29. So which two are the legs of the triangle? Which are A and B? Which are the two shorter sides? Jasmine,
39, 29.
Yes, 39 and 29. It doesn't, the order doesn't matter. You could make A 39 and B 29. It really doesn't matter. The hypotenuse is always the largest side. So what I'd like you to do is do the A squared plus B squared equals C squared. Determine if 39 squared plus 29 squared, does that equal 54 squared?
The 54 is bigger than.
Yeah, so good. And so let me go grab this again. What I think I heard, then there's just a tiny bit of communication I'm just missing here, but what I heard is that the 54 squared is greater than the other numbers squared together. Is that right?
Yeah.
Yeah, so 54 squared is 2,916. And that's what you got. And then 39 squared plus 29 squared is 2362. So yeah, this is an obtuse triangle. And it's because the square of the largest side is greater than the other sides. Is that clear?
Yeah.
Great. Sorry, I know this stuff is not interesting, but we do have to, we do have to muddle through this. Are your tests on Delta Math, or is it just for homework? Do you, yeah, do you have tests in person, or are you doing them online? Or I'm sorry, yeah.
We're supposed to be doing them in like class. I don't know.
Okay.
As the test open still, which is
Got it. Okay, so let's look at another problem here. It says the sides of a triangle are 45, 55, and 32. So which two are the legs? Which are the two shorter sides?
45 and 32.
32 and 45, yep. Okay, and then the hypotenuse is 55. So again, a squared plus b squared equals c squared. You want to write this down until you roll out of bed and you know it. 32 squared plus 45 squared. Does that equal 55 squared?
No.
So did you get these two numbers?
Yes.
Excellent. Okay, so let me grab this picture again, and you tell me which one is it? And this is c squared. It's definitely not equal. Yeah, it's acute. Perfect. Yeah, and it's acute because the square of the largest side is less than. I'm sorry. Yeah, is less than the sum of the squares of the other sides. And so you're going to be asked this on a test. Like you're going to be expected to know how to do these on your own. Okay, so let's try one more here.
Yeah.
So I want you to try this one on your own, please. Let me snip it in. All right, so go ahead and give that a try, please.
Um, 48 squared and 71 squared is 3 squared.
Yeah, did you get 7,345 for 71 squared plus 48 squared?
Yeah.
And then what did you get for 83 squared?
189.
6,889. Yeah. Okay. So if we go back and it's really nice when you got this picture, and I would like have it on in your note sheet or somewhere handy. This is c squared. This is a squared plus b squared. Is it obtuse or acute?
Acute.
It's acute again. Yeah. All right, so they're less than. All right, so we've actually done 4 of the 5 questions in both of the Delta Math sections that you wanted us to look at today. I hope this gives you a better idea of like what the lessons will look like. We can literally go over anything you want during the lesson time, and we can go through homework, we can prepare for tests, we can go through old test materials, whatever you think would help you. This time is specifically for you, like whatever you think you need. And so again, I'm going to send you an email with the notes at the end, and I'm sorry that I didn't send the email to you initially. I definitely would have done that. I thought mom wanted it to go to her, so But next time we should be able to start right on the hour and, get a lot done. So do you have any questions for me, or is there anything else that can answer for you?
No.
All right. Well, thank you so much for letting me get the chance to help you, and I hope we get to work together again. And that is it for the lesson for today. I'll definitely be calling your mom at some point and giving her some feedback, and hopefully you guys want to continue with the lessons. All right. Thank you so much. Have a great day. Okay. Gonna
Thank
log
you,
off
you
now. You're
too.
welcome. Bye now.